Okay, on to number 4 in our independent practice. So this one kind of asks a lot. It's pulling a lot of different stuff from polynomials into this one. So let's try to use what we know to solve this. Okay, so we have our polynomial x cubed plus 6x squared plus 11x plus 6. Okay, and we're going to state what are the maximum number of zeros. Well, the maximum number of zeros is always equal to the degree. Okay, so in this case, we have a degree of 3, and so we have 3 zeros, okay? And let's see, part B says our maximum number of relative extrema. Now, I'm going to go ahead and point out that this is the same as turning points, okay? So your turning points are actually the same thing as the degree minus 1, okay? So if my degree is 2 or 3, this time I have 2 turns or extrema, okay? So turning points and extrema kind of go hand in hand because a turning point is basically an extrema. So when we solve for the maximum number of turning points, we are also figuring out how many extrema we can get, okay? And then part C, the end behavior, okay? So remember, end behavior always goes in pairs. We're going to talk about as x goes to negative infinity and also as x goes to positive infinity. So these represent the left and right hand sides of your graph respectively, okay? And each side is either going to be going up or going down. So we're going to have an f of x is doing something associated with that. So let's now think about what's happening here. This polynomial has a degree of 3. It is an odd degreed polynomial, okay? And if you are an odd degreed polynomial, then you know what? That you are going down on the left side and up on the right side. And if you were negative, you would flip these arrows, okay? So my first side, the x approaches negative infinity, that's the left side. We are going downwards on the left. So I'm going to say, hey, this is negative infinity. And on the right side, we're going upwards. So we're going to say that's positive infinity, okay? Note these are going in opposite directions. Their signs are opposite on that f of x value. Okay, now let's look at part D with this polynomial. Let's figure out how many positive and negative zeros we could have using our P&I chart, okay? So x cubed plus 6x squared plus 11x plus 6, okay? So the first thing I will note is all of these are positive. There are no sign changes. So I'm going to see here that there are no positive zeros. Okay, so we cannot have any positive zeros. Now let's check the negative zeros. Okay, so what I will tell you is we plug in negative x, okay, but just flip the signs on the odd exponent ones. Okay, so notice I'm only changing the 11x and the x cubed. The other two are staying the same. Okay, and when I check the sign changes here, I see 1, 2, 3. There are 3 negative zeros at max, right? So let's set up our little P&I chart. So here we go, positives, negatives, imaginary complex, and total, okay? So in total, I should always have 3 zeros. It's equal to the degree, right? So in total, I'm going to have 3. Currently, I know I have no positives, 3 negatives, and to get that to add up to 3, I'm going to say there's no imaginary zeros as well. Now, since complex numbers move in pairs, I could take 2 away from here and make 2 imaginary zeros, leave only 1 negative zero, and still get that total of 3, right? So with this combination, we have another combination that would work for the P&I chart. And then finally, guys, let's use our rational roots theorem, okay? So what we're going to do is we're going to come up with a list of the possible zeros, okay? And it's just going to be the P over Q list again. So factors of 6 over factors of 1, okay? And it's always plus minus, remember. So 1, 2, 3, and 6 over 1, okay? And then we end up with something like this, plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. Now note, if you were guessing an answer, if you were trying to figure out what the actual answers were to this, you should not guess 1, 2, 3, and 6. You should only be guessing negative numbers because we knew that there were actually no positive zeros in this problem. Okay, but in this case, they just wanted us to make the list. So here is our list of factors, and that will get us to the solution that we